In this video, I will be explaining the galvanic series and the cathodic protection method for the prevention of corrosion. In this video, I have explained about corrosion and its mechanism, giving special emphasis to wet corrosion. So then we have mentioned that a metal which is getting corroded is acting as the anode and is undergoing oxidation. So a metal with lower reduction potential will have the tendency to act as anode. So if you compare the metals titanium and silver, if you look at the reduction potential, right, titanium has a potential of minus 1.63, whereas silver has a potential of 0.80. If you compare the potential, you might think that titanium will be getting corroded faster because the reduction potential is low and it will be more anodic. But in real case, it is not. Silver will be getting corroded faster than titanium. You can take another example of aluminium and zinc. If you consider the reduction potential of aluminium, it is minus 1.66 and that of zinc is minus 0.76 volt. So the potential of aluminium is low, so it is expected to corrode faster when compared to zinc. But actually, zinc is getting corroded faster than aluminium. You might have studied that there is an oxide layer formation in the case of aluminium which acts as a protecting cover. So we cannot always use electrochemical series for predicting the corrosion tendencies. So there is a more practical series which is used for predicting the corrosion tendency, and that is known as the galvanic series. Galvanic series is a series in which metals and alloys are arranged in the order of their corrosion tendencies. So it's the electrochemical series where the metals and non-metals are arranged according to their reduction potential, but galvanic series is a series in which metals and alloys are arranged in the order of their corrosion tendencies. It is prepared by studying the corrosion of metals and alloys in unpolluted seawater by measuring their oxidation potential using calomel electrode as the reference electrode. So the electrode will be metal or alloy and electrolyte will be unpolluted seawater. So we will be measuring the oxidation potential using calomel electrode as the reference electrode. So this is the galvanic series. Magnesium alloy, zinc and all that. A metal high in the series is more anodic and undergo corrosion faster. That means if you look at this series, magnesium is the one which is undergoing corrosion faster compared to other metals, followed by magnesium alloys, then zinc, aluminium. And you come here, platinum, you have platinum at the end. That means platinum is the least corroded one. Okay. So here you can have a look at zinc and aluminium. So according to galvanic series, zinc is getting corroded faster when compared to aluminium. And also we can have a look at titanium and silver. If you look here, silver is getting corroded faster when compared to titanium. A metal high in the series is more anodic. That means the metals which are coming here, coming to the left hand side will be more anodic, and the metals which are coming at the back will be more cathodic. So now we can list out the difference between galvanic series and electrochemical series. Galvanic series is arranged based on corrosion tendencies, whereas electrochemical series, the reduction potentials are arranged. Zero is measured for metals and alloys, whereas in electrochemical series, it is the reduction potentials for non-metals and metals. The potential is ordered by dipping metals and alloys in unpolluted seawater in the case of galvanic series, whereas a 1 molar salt solution is used for measuring the potential in electrochemical series. The calomel electrode is used as the reference electrode in the case of galvanic series, whereas standard hydrogen electrode functions as the reference electrode in electrochemical series. The galvanic series positions of metal and alloys may change, whereas it is fixed in the case of electrochemical series is used to predict the corrosion tendencies, whereas electrochemical series will be useful to predict the reactivity as well as the displacement tendencies. So these are the differences between galvanic series and electrochemical series. Another parameter which is used to measure the corrosion rate is corrosion current. We have already discussed that one. Corrosion current is the flow of electrons from the anode to the cathode through the conducting media. The corrosion current per unit area is used as a parameter for measuring the corrosion tendency of metals and alloys. Corrosion current is measured by coupling the metal with inert electrode like graphite and immersed in seawater. So you have electrodes of metal and graphite and which is immersed in the electrolyte of seawater. So seawater, instead of seawater you can substitute 4% NaCl also. So it is not easy to have pure seawater always. So you can use 4% NaCl instead of seawater. Now let's move to prevention of corrosion, cathodic protection. So there are various methods for the prevention of corrosion, like simple things like painting, oiling, etc. So in the syllabus you have to study only the cathodic protection. As I said earlier, when a metal is getting corroded, it is acting as the anode. For protecting the metal, you have to convert that metal into cathode. When it is not acting as the anode, it will be protected. That means the metal to be protected should behave as a cathode. So there are two methods for cathodic protection. The first one is sacrificial anodic protection or galvanic protection. The first one is the sacrificial anodic protection. Here metal which is to be protected is made as cathode by connecting it with more anodic metal. So for example, if you want to protect iron pipe, you have to connect it with more anodic metal. More anodic metal means a metal which is having lower reduction potential than the metal which you want to protect, then that metal will act as the metal with lower reduction potential or which is more anodic will now act as the anode, and the metal which is to be protected will act as the cathode. So this is sacrificial anodic protection. So you have to make the metal which is to be protected as the cathode. This can be done by connecting that metal to more anodic metal. More anodic metals like magnesium and zinc, then that will be acting as the anode and your metal will be acting as the cathode and it will get protected. So this method is generally used for protecting underground pipelines, cables, ship hulls, etc. The next method is impressed current cathodic protection. Here the metal which is to be protected is made as cathode. So for making the metal to cathode, we are applying impressed current. So impressed current is applied to convert corroding metal from anode to cathode. A direct current from a DC source is applied to an anode. So generally anode will be graphite, which is buried inside the soil and to the corroding metal structure to be protected. So normally the graphite will be acting as the anode and the metal which is to be protected is acting as the cathode by applying direct current, DC current. So a DC voltage is applied such that corrosion current becomes 0 or negative. That means you are applying a voltage in opposite direction as that of corrosion current. Then your metal will be acting as the cathode and graphite will be acting as the anode. Ship's dockline harbors are generally protected by this method. So this is the schematic representation. A graphite anode, a graphite block which will be acting as the anode, and the metal you want to protect is acting as the cathode by applying a source of impressed direct current. Okay. Thank you.